Okay, can you see my screen yet? Okay, thank you.
Yes, I can see it.
Okay, awesome. So let's start with let's start with some of the last module for today, which is the last two services that I haven't talked about since last week is the Azure Polybase and Stream Analytics. We have been go through. Let me go quickly overview with you some of the things that we have went through. So we went through the storage options and how are the services that we use to like ingest, like ingest and serve all of the data that's stored in the storage and how to move the data to the storage. And we didn't talk much on the architectures, or we didn't talk much on the how these services cooperate with one another to create a data architect platform for Azure. That will be the next session. We'll go through the last two, which is Azure Polybase and Azure Stream Analytics. Then we will start to share. I'll start to share the next one, which is on the data architect. So first, let's see what is Azure Polybase. So you have one side in this picture. One side you have like relational data, and one side you have unrelational data. So the relational data is presented by RDBMS. Relational database, and Hadoop, which is like you can, of course, Hadoop you can use it to store relational data, but it also can store unrelational database. So Polybase, as this picture present, it sits between these two, so that it provides a scalable TSQL comparable to help processing both relational and non-relational data with TSQL. So in the past, it was really difficult to join that with external data. So you have to like transfer data in one format or the other. You have to like have the format which is the same between relational or unrelational, or you have to like query both of the source of data, then write custom query logic to join and integrate the data and add the client to server together. So basically what I just mentioned is like when you have a relational data and when you have an unrelational data, there will be a lot of steps in between, um, so that you can like analytics these two. And normally if you want to analytics two format together at the same time, then you have to convert it to, from one format to the other. So I can give you an example of a company that I was looking at. So for example, if a company, for say they have a lot of data that they collect through their sensors, and the sensor data is often come with JSON format. So but then all of their other data is relational database. So relational data, so data from finance, data from other departments, data from accounting. So they want to have a big pictures of how the sensors cooperate with the finance or the accounting or the departments. So they have to translate these data to a relational data. So they were so proud of themselves that, like we are one of the first company to convert the census data to a relational database to store in SQL Server, and we can query data out of it and make automatic analytics and automatic control of the sensors based on these data. So when I say this story, I just want you to understand the difficulties when you have both relational and non-relational data, right? So that's why they have two unpleasant options that I mentioned about. You have to convert the data format, or you have to accept that you will have to query both source of the data and just build custom logic to be able to analyzing them together. So where is the Polybase come into the pictures is that you don't have to do those steps. They use TSQL to join these data and to keep it simple. So, it doesn't require you to install additional software to your Hadoop environment. You just query the external data, use the same TSQL syntax that you use to query the database table. And yes, and the query author doesn't need any knowledge about Hadoop or how it's work underlie. So it just, if you use SQL, TSQL, and you just keep using it. So it makes things very simple. You don't need a separate UDF, user-defined function, for particularly processing these JSON and database, unless like you have specific case that you want to create. So that's what the role of Polybase is. So here we will go through some of the use case of Polybase. So before I go any further, I'll just use these three cubes to give you an overview pictures first, and then we'll go over in a little bit. So some use case is like we load the data and with interactive queries. So that is the big portion that I was mentioning you about. And we use it to age our data for HDFS and use it as code, but queryable storage. So remember, we were talking about cold storage tier is something like we don't use it often, but still like we keep it there and we still want something that queryable. So in time that we need to query, then we can use it. So SQL, Azure, they have a good document on the some use case, and let's take a look at it. Sorry, give me a moment. I'm copy and paste this in my, okay. So in here, as you see, is also go very brief, and I have other supplement materials that we can go in depth, more in depth in this Polybase. So in here, some overview of the uses of Polybase, like you can query data store in Hadoop from SQL Server. So you know, remember when I talk about data lake, or when I talk about HD Insight, remember the data that underlie, or like even Azure Databricks, and you remember when I say that the underlie the underlie file storage is HDFS, right? So Hadoop is an umbrella terms, and we can use it. It's an umbrella terms, like you can talk about the Hortonworks technology. You can talk about the Hadoop as the whole structure for big data, or you can talk about HDFS, which is Hadoop file storage system. So it's a really umbrella terms. And in this here, we are talking about any of these. So Hadoop is used for big data, and Polybase makes it easy to query the data using TSQL between Hadoop and the server. And also, we query data store in Azure Blob Storage. Remember when I mentioned about before, Azure Blob Storage is the cheapest thing to store data, and normally it's a flat file structure. So it's not the hierarchy file structure like Hadoop HDFS. So you can query data, but you have to aware that it's a flat structure type of query. It's not like you have folders and subfolders and things like that. So those are the three like structure which happen in the data lake store or HDFS. And normally, if you can store a query from blob storage, then for sure you can query on the data lake, because data lake is built upon the blob storage. Remember? So so in here, it's just the extensive talking about Hadoop blob storage and Azure Data Lake, because once you query, then you can manipulate, you can export, you can import data. So it's just more or less common sense with it, and integrate with the BI tools. So in here they talk about other Microsoft Business Intelligence and Analytics stack for like Power BI, for example. So you can like interact with these tools, and you can query, you can help facilitate the query information. So in here, let me share with you some of the slides. It's not prepared by me, but it's from another. Hang on, let me share with you first. Okay, so this is the supplemental materials, and a lot of it won't be in the exam. But since we agree that we'll go a little bit in depth, so I want to talk about this as well. So of course, these are some of the principles, and a lot of it is advertising. Like best in class performance. So just remember, basically, it can query both data from data warehouse, or blob storage, or the one from Hadoop, and it works with both relational or non-relational database. So here are some of the structure, and I really want to stress out on the learning of structure or like pattern, because in the exam they will give you use case, and you need to reference back to the pattern or the structure to see how it works. Because once you have like pattern in mind, and once you see the cases, you can just apply it to the cases. So so you see here, this is relational. Can you see my arrow? Let me see if I can annotate. Yes. Awesome.
Yes, I can.
Yes. Awesome. So you can see here relational data. You can see here is Hadoop, and this is where the team that use data, that process data from. So here is all of the Office stack in here, and you have external data source, external data format, external table, and Polybase in here is help facilitate the query processing in the all of these architecture. So it sit in between. You can you can connect to the data source from data warehouse, from Hadoop, or from your Excel, your Access, and Power BI, of course, to all query and to all like gather the information in one place and make it happen. So next. So again in here, and let me know if you get confused on this, because I don't think I have talked about this in our fundamental course. So let me know if you have question on this. So split-based query processing, uh, the key principle is leverage compute power of Hadoop. So there's so before, so like in Hadoop, like if you use pure Hadoop, then you need to have the knowledge on MapReduce, which is MapReduce, which is like if you want to like further processing it, you will need to know Java, and for Databricks, you need to use you need to know you need to know Spark or PySpark. And with what is the advantage of the APS with Polybase is that you don't need to know any of these. You just need to really know SQL and TSQL in fundamental. So number one, the benefit is number one, you need to know SQL, and number two is reduce the data volume to be transferred, because basically you don't need every data in one platform. You can query out of like data warehouse of other sources to get just the data that you need. Because normally, and you will learn in the next section of the class, is that you know, like in the enterprise architecture, sometimes you don't dump everything in a data lake. You have like data warehouse, you have different data store in SharePoint, for example, and you have data lake, and sometimes, you know, synchronize everything in one place is not possible. So well, it's possible. It's not like the best optimistics for the enterprise. So sometimes like have something that sit in between and just query the data that you need would be a more achievable option. So further on this, and let me share with you on here, because you also can see the same information on the, oh, sorry. Oh, I think I lost this. Oh, I think I lost the window. Hang on. Oh, no, okay. And you can see this also in the documents in the same page in here. You can also see it here on the, because they all get information from the same source. So if you get confused, you can go back to the concept, query scenario, and these are all the information that they will talk about. They just put it in this slide basically. So you know, like you use select to run TSQL over HDFS. So basically what they do is just they explain for you further and more extensive. But if you get confused and you just want to learn the fundamental for the exam, then you can just go back here and see some of the apply of Polybase scenario, like how you select, how you join, like, you know, how to join external table with local tables. And, you know, basically everything in here is fundamental of SQL, you know, import data, export data, so very fundamental. And if you want to go in depth, you want to see how it connects to different data source, then you can see it more in here. And I'll post this material on our GitHub study group so that you can see further more on this. So let's go back. Oh, hang on, let me stop share here, then start share on the other computer. Okay, so for that we have conclude the Polybase. Oh, hi Stu. So oh, hi guys. Wow, you so many people today. I hope you guys have a really good holiday seasons, you know, like with the new year approaching, and December, which is you know, often holiday season, and November too. So hope you guys will have the fantastic months, and ready to welcome the new year. So we will just go over on the Azure Polybase. I just want to have a brief word on it again. So it's basically help you to query both a relational and non-relational database of the data that external data source across your data platform. So for example, if you have data in the database, if you have data on SharePoint, on Excels, you know, if you have data on your Hadoop data lake, for example, it helps you to query data from multiple sources without have to transfer all of the data into one place, without having to convert the format of the data into one format, you know, for example, JSON to JSON to you know, like SQL, you know, relational database, for example. So you don't need to do that in with Polybase. So it really helps you to cut down all the complication steps to analyze data from different sources. So that is the main goal and main purpose of Polybase. So let's see on the next one. So after we talk about this one, then we will conclude all of the services that we have for Azure. So just briefly again, we went through Azure storage, like different Azure storage options. and we go through to like other support service that will be tested on DP200. And after this, we will start another presentation on the Azure Data Architects, because we'll go in depth on the architect type and different architect patterns, and different on in depth on how all of these services connected and play it roles in the landscape. So let's go to this one. Sorry, give me a moment. So basically, I hope you can see. I hope you can see this architecture. I think it's a little bit blurry. Let me move the sidebar up to see if it's better. Okay, it will disappear. Okay, it will disappear. So you should have the full picture of the services now. So basically, this is the model of the hot data path. Remember, I was talking about the Lambda architecture where you have the hot path and the cold path. So this represents the hot path where you have data from different devices and you go through the IoT hub, and then you have the stream analytics to help you process the streaming of the data and put it in like SQL database. But of course, you don't have to like just put it there. You can stream data to Power BI service and visualize it on dashboard. So it's also an option. But I want you to know like how the architect of Azure Stream Analytics play in the whole Azure stack. So basically, what is Azure Stream Analytics? It's a real-time analytics, and it's a process event, a complex event, and it's designed to analyze and process high volumes and fast streaming of data from multiple sources simulatedly. So you remember we have you might have heard a lot about Kafka, where you also do similar thing. In Azure, there's a specifically service for that, which is Azure Stream Analysis. So with Stream Analytics, you can identify pattern and relationship and from multiple different sources of device or click stream on multiple media feeds or application. So basically, I'll tell you some of the scenarios that you can use stream analytics. For example, you analyze real-time telemetry stream from IoT devices, which is what these pictures can show you. Or you can analyze web logs, clickstream analytics. For example, if you have platforms of, for example, like Amazon, right? Well, Amazon, they would use AWS, but in theory, or eBay, right? So you need to analyze the clickstream analytics. Then this is the service that you can use. You can remote monitoring and predictive maintenance of high value assets. For example, if you have, like I mentioned with Harris early on, like if you have a factory and you have like different, different camera to monitor assets, and how you predict like when the how you monitor the sensors in that factory, how you know like predictive when the factory will occur some failures in the process stream, then you can use stream analytics. And you can do so much with stream analytics, like you can help to control and to detect anomaly with stream analytics and AI in cognitive services. So let's go to the Azure documentation to see if to see some more information on this. Let me start sharing on my other computer. Sorry that we have to switch between these two, because I put these slides in each different place. So let me share it here. Okay. So in here again, we have another, well, it's not the architecture, but it's how the flow of the data in the data architect. So you always have something like you have the ingest, you have the place to analyze, and you have the place to deliver. And you know, a lot of times you will have a place to store too. So remember this keyword when you design a data architect. You need to consider about a place to ingest, a place to store. In this case, yeah, in this case, they doesn't mention about storing it in particular place. Oh, here, reference data block storage. So this is the place to store, but you can clump up as the place to analyze. So depends on the picture that you draw, but always you have to know like where you ingest, where you analyze, and where is the deliver. So you will see these keywords over and over again, and remember this in the test also. Remember these, like ask yourself where you ingest it, where you analyze it, and where you deliver it to help you select the appropriate 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 tools for the scenario. Okay, so what you ingest in here? So you ingest stream data, and you have three type of ingest platform. In here is Event Hub, IoT Hub, and Azure Blob Storage. So all of these are ingest path. So it basically just ingest the data. Don't confuse it as analyze data. All right. So if in the test they trick you and they ask you, you know, like whether IoT Hub and Event Hub is for you to analyze data, the answer is no. The answer is these all just ingest the data. To analyze, you have to use stream analytics for real-time analytics. It's not for batch. It's of real-time analytics. So once you analyze it in real time, that you start to deliver it in, for example, Power BI, Azure Synapse Analytics, which we learned about it in last time, and you can deliver it to storage for a retrieval or archival. So what are some of the capabilities or benefits? So I won't go in depth, but look at the headline only, so it's easy to get started, and it's understandable because it's in the same platform, and it's serverless. So again, in here, it well integrated with a different platform that Azure already have. So you know, PowerShell, CLI, and Stream Analytics, Visual Studio Code. So there are already tools that support the development of Azure Stream Analytics, and of course also with other languages that are available in here, and it's fully managed. So remember PaaS, which is a platform as service. So it provides a platform for you to build, and it's different than infrastructure as service. So with infrastructure as service would be something like you get a VM and you install a Kafka in there, or you install a Spark streaming on there, and you have to like fully manage the VM and also the Spark or Kafka on there. In this, you just have to manage the platform. You don't need to worry about the infrastructure underneath it. So you see, you can focus on the business logic, but not the infrastructure. So you don't have to worry about like when you need to update the next batch, when like conflicts of software installed in the infrastructure. So it saves a lot of time. I'll tell you this. And it run on cloud or on edge. So IoT edge, you know, Azure Stack, which is like on edge devices, and it's low cost of ownerships. So remember all of the bold point, because once you remember the bold point, then all of these self-explain, we already know that, we kind of already know that through our session. So just focus on these to analyze the benefit. I believe in Azure 201, there will be more questions on implementing and design, well, more questions on design on designing the services. So a total cost of ownership, you know, because you don't have to worry about the infrastructure. Mission critical ready. So when you see this, it means like you can have it available across multiple regions worldwide, and it supports to run mission critical workload. which is your reliability, security, and compliance with requirements. So the thing about platform as service and software as service is that it's already built with the scalability and availability. So of course in here, like again, it's related to mission critical because 99.9% availability because it's available across multiple regions. So all of these are like repeated information of other Polybase before that. So just remember the benefit of Azure Azure Stream Analytics is that is on cloud, so it's well integrated with other tools from Azure already. It's scalability mission critical, and it's hang on, sorry, and it's security, hang on, sorry, it's security, it compliance with other tools that are available, and it's scalable, it's a real-time analytics platform for gathering the data. So that's it for this session on the services. And let's start with the Azure Architects one. We have 20 more minutes. Okay, let me start share on this. I haven't posted this link on the GitHub yet. I'll post it on later. Oh, let me share with the class first on here. Hang on, let me share here first. Okay, I'll post the same link on GitHub later today. So you guys, before moving to this section, do you guys have any question on the previous one? Let me go back on that first before we move to this one. I think the link is already on here, but let me know if you have questions first, because these are really critical for the exam. For sure, like they will ask you on these services because it already specifically mentioned on the exam guideline. Oh, I don't know why it doesn't appear on chat. It's so weird. Hang on. Okay, that's good. So let me go to a bullet point real quick, then we will move on in the other one. So remember, for storage solution, we have query storage, table storage, blob storage, and here it's just virtual machines, so you don't have to pay attention so much. But remember, really pay focus on blob storage. CosmoDB is a huge section for the exam. CosmoDB API, of course, is very important. Any materials that you can help you learn more on CosmoDB and Azure Databricks, do it, because CosmoDB is a strength of Azure, and Databricks is something that Azure just acquired in 2019. So for sure they will test on this, for sure they will push on it. So pay attention a lot on these services. Again, CosmoDB, a lot of links for exercise lists. We didn't have time to go through it on the class, but let me know if you want like one session to just talk about CosmoDB and Azure Databricks, and we can do that. Talk about like comparing different API, and the blob storage is not like a huge, it's not a huge focus. They elect Gen 2, remember, in this exam, after November 24th, they make some change and they will only test on Gen 2 architecture. So just focus on study on this. Azure SQL, so you have three options: virtual machines, managed instance, and database. And for this class, they will focus, for this exam, they will be really focused on the database. And the other service that will be tested is Synapse service. So data factory, data bricks, a huge important. Please take time to learn on this. Azure Monitor, Polybase, and Stream Analytics. Okay, so since you guys don't have any question yet, okay, since you guys don't have any question yet, so let's move on some of the slides here. And I have prepared a lot of slides. You guys can see it in advance, and we'll go through a few more sessions. I'll explain more study groups on the more study group session on this. The last session is supposed to be next week, but let's go in depth in the more on the architecture patterns and data patterns, so we will have adequate knowledge to prepare for both exam 200 and 201. Oh, and also, do you guys have any date that you need to specifically like do you guys book the test yet? Like you have like a specific date that you need to take the exam, then let me know. Then we will hurry it a little bit and focus more on the exam. But if you guys hasn't booked it yet, then we will go slow and we'll go in depth on the architecture. So it's up until like this part is really up to you to control the flow. So let me know what is your goal and what is your exam date. Okay, so in here before we start, we let's revision on this. We have relational data. It's built on ACID model. It's a proven security, privacy, dependable performance, operational data, because you have all the restriction that you can make sure that your data is restricted to the like to really adhere to a certain format, because it's a schema on write. Remember, relational data, when you talk about it, you always need to remember about schema on write. And big data is fast exploration, of course, because we have like data from all over devices and different data sources that we need to gather. Is from semi-structured data to unstructured data. So everything is put in the data lake, and the data is expanding and a lot from a lot of multiple sources. Is big data. So what I want you to remember in this picture is similar to what we discussed on the fundamental data engineer, where we could talk about acid and base and how schema on read and schema on write. So these pictures, I hope you guys will remember about that session that we go through before, and a lot of the concepts that we mentioned on this section will be related to what we studied in previous session. And that in my style is that I want to repeat the points so that you guys could remember it well, because we only have one session every week. So repeating things could help you help you remember things better. So before we move on, I just want to introduce to you guys one part in here that I post during this weekend. Is in Big Data Engineer, and it's really good. It's from Databricks. It's called a modern cloud data platform for dummies. And in here it's talk about lakehouse, which is a new concept where they combine data lake and data warehouse. And of course it's not on the exam, but I really like how recently Databricks has a lot of good materials for people to understand about cloud data platform. And I would encourage you guys to read it, because you will it will help you to understand not only Azure Databricks, which is a product of Azure now. Databricks is acquired by Azure, so it's a product of Azure now. But how it will integrate with the modern data platform, and they have very good engineer there. So please, when you have time, go ahead and read this. Okay, so let's go back on this. Big data portfolio. So you remember on my other sessions, we always talk about scale up, scale out, and on-premise, on cloud. So how all of these fit on the portfolio on here. So on-premise we have a server, SQL servers, and when a company wants to move from on-premise to cloud, then we also have Azure SQL Database on cloud or SQL Server in Azure. So it's remember when I talk about storage options and I mentioned about Azure SQL and we have three options, right? Like on VM, on the database. So these are all on cloud and you can scale up. So basically, scale up is like you can have multiple instance and it will scale up the workload for you. And scale across, that means like you can scale out to other services and scale across different regions and different different regions and different backups. So we have SQL data warehouse, we have Databricks, we have Cosmos DB, HD Insight for this. And for this exam, you don't need to worry about HD Insight. You just focus on Databricks and Cosmos DB, and you can see that in the portfolio, it fits that is scale out and scale across. And remember, scale across means that you scale across different regions. And also remember here the key which is relational and which is non-relational. So yes, so remember this part because it will be very crucial for our exam. Okay. So we also talk about cloud storage solutions, but it really like on concept. So how does it fit? Sorry, how does it fit into one picture of overall data architects? So of course in here, diff storage, don't worry about that. They're not going to ask about that, but you really need to remember archive tier, cool tier, hot tier. Remember we talk about it in the blob storage. If you forgot this, go back to this slide about archive, cool, and hot. So all of these, we have automatic lifecycle management, where you set the rules to manage the life cycle of the data spontaneously and automatically. So, at certain time, you move from hot tier to cool tier and to archive tier. And on top of the blob storage, remember we talk about the file system. So here are the file system and the API to process it and to interact with it. And in this area is where the edge device are sending and moving the data to. And in here where the caching layers, and we have so much to talk about the caching layers for like different caching type, Redis for example. And I don't think we'll cover it in the data engineer at all. I'm not sure which certificate they will ask you on Redis, but it's very, very important. Well, not important, but it's well, if you want to be a cloud architect or data architect, then Redis caching is something that you need to look into. So in here is the serving layer. So you have analytics engine like Spark. You have Azure Databricks, where you can perform AI and machine learning, and you have other high performance compute. So depends on your usage, you will more interacting with this layer. And with this layer, you send a command that achieve the data from all of these lower layers. Okay. So one thing that I want to talk to you guys about, and I don't think I mentioned much in the other slices, which is data loading and data transport. So when you have the data in storage, how you load the data to your storage and how you load it out of the storage. So here are some of the tools. So you have file sync, which is like between Windows Server and Azure, local caching. So you have fields, which is like malloc in your local FS, on your Linux, on your VM, and side replicate, where like you have different machines and you replicate the data. Network acceleration, So to in short, let me let me tell you what will be in the exam. AZ copy, it will talk about AZ copy just briefly. You need to know what it is. It's a data transport method. I mentioned about this when we talk about blob storage. So go back on here and you will see AZ copy. Let me see. Oh, that not help. AZ copy. Okay, let's see copy. Yes. So AZ copy tool, so it's a type to ingest the data. So it is a part of AZ copy is a own tier. Pay attention to data factory, pay attention to housing. So these will be the one that tested on the exam and is the method to transport the data. So data loading, so once you transport it and how you load the data to use it. So in here you can have like different tools and enterprise tool like SSIS or like third-party tools. You can talk about like Nifi, Airflow, I talk about it a lot. And yeah, third-party tools are two of the Azure services, which is Azure Data Factory and Polybase. So these are the Azure loading tools. And another important concept before we start to move in the ingest, like how modern data warehouse is built, what is in each of these layers and how the patterns. So before that, I want to mention again about storage replication options. So these could be tested not only on the DP200, on AZ900, on AZ104, and a lot of the exams on Azure Architecture. So, AZ304 also. So it's a very important slide if you plan to learn it for all the exams. So remember how the data is replicate and how it's how it's synchronized. So you have here is LRS, which is like multiple replica across a data center. So it doesn't necessary to it's in one zone, but then it's replicate across a different data center. So it can protect you against like this node, rack values. And it has SLA of 99.9, and it's the common SLA throughout the services of a lot of Azure exams. Of a lot of Azure services. So zone replicate Z for zone. So anything when you see Z, remember about different zones that it has. So it replicate across 3 zones. So not only it protect you against this node rack value, it for example, if you have the data in Singapore, what happened if the whole country, for example, got a power outage, North Korea shoot the nuclear warfare to Singapore. What happened? The whole country is, the whole country is have the network failure, right? So, but if you have like 3 different other zones, for example, in America, in Europe, then you will know that your data is still available in zone 2 or zone 3 in Europe or America. So that is for zone replications. And remember, this is your responsibility to back up, to select the options that fit to your business. Because if you don't do that, and if something happened, then you cannot blame on Azure fault. So you always need to remember, not only for your business need, but also for the need of the need for backup, and you need to consider the need of your business usage or backup, and the need for your data. So whether you need to have it available in 3 option zones, or your users in mainly just in one zone, so you don't care about other zones that got replicate, and you would prefer to choose the option of like replicate on a different data center, which is the default options. So it really depends on your business. But remember, if you don't choose, if you choose one and later on if happen because of your choosing, that is your fault. The SLA here is protect 99.9%. Okay, so GIS. It replicates across 2 regions, and it protects against a major region disaster. So remember, when I talk about GI, when I talk about the other situation, it's asynchronized to secondary. So you have the primary, and the primary is always available, and the secondary options is asynchronized. So that means it doesn't get the latest data. So it's not strong consistency. It's asynchronized, that eventual consistency. Remember, when you say asynchronized, always think of eventual consistency. This one is strong consistency. All right, remember about the distributed system that I mentioned on the Azure, on the data engineer fundamental, where I talk about strong consistency and eventual consistency. So you are starting to see these concepts in these slides, and you will see more and more of that in when we reach about the architect patterns for distributed system. Okay, so we talk about RAGIS. So it's basically it's a GIS, but it have the read access to secondary, and it separate secondary endpoint. And it also have the SLA of 99.9 of read and write. Okay, so let's stop here, and please go ahead and look at these slides first. So I'll try to cover all of these slides in the next one. So after the next session, then we talk about the architect patterns. And after that, and we will talk about architect pattern of warehouse, data warehouse, and of the data lake, and other other architectures that will help you to address the scenarios in the exam. So thank you, you guys. You guys have any questions?
No, thank you, Jane.
Oh, oh,
No, thank
awesome.
you.
Thank you so much for joining, guys. See you next week. Bye-bye.